Hey there, students. Want to show you how to find probabilities for a Poisson distribution. This is from Chapter 5, Section 3, and I'm specifically looking at homework number 32 on our homework set. And if you notice, there's this T in the numeration of the problem, which means that this is a technology problem. So they're expecting you to use technology, and I'm going to demonstrate, of course, using StatCrun. So the problem says, in a recent year, an author wrote 196 checks. Use the Poisson distribution to find the probability that on a randomly selected day, he wrote at least one check. And then they ask for the probability. So it does tell us specifically to use a Poisson distribution, so that helps us recognize that that's the tool that we need to use. So let's just go find that tool. Again, there's no data set to open in StatCrun, but I do want to use StatCrun, so I'm going to go to Question Help and click on StatCrun. And then in StatCrun, the calculator for a Poisson distribution will be under Stat Calculators, and then on the list you can go down to Poisson. So Stat Calculators Poisson. So if I click that, it basically looks like the binomial distribution, where you have probabilities for each individual possible number of occurrences. But of course, it stretches from none off to an arbitrarily high amount, which is the nature of a Poisson distribution. Now, what the Poisson calculator wants is the mean. There isn't a set number of trials. We need the mean value. So the mean will be the total number of occurrences divided out over the total number of opportunities for those occurrences. So in this case, it says in a recent year, the author wrote 196 checks. So 196 checks is the total of how many were written, but that's spread out over the course of a year. And they're asking about the chance of how many we got on a particular day. So the spread for the Poisson distribution is over days in a year. There's 365 days in a year. So to find the mean value of how many checks were written over 365 days, I would divide the total of 196 checks by 365 days to get the number of mean checks per day. So I'm going to grab a Windows calculator for this real quick. And I'm going to go 196 divided by 365. And so that means that there was a mean of a little bit more than a half a check per day. So I want to put the mean value in here. Now, they're not asking for the mean, so I don't know where to round this off. So I'm just going to grab a bunch of decimals to hopefully have plenty of accuracy. And then pop that into the mean value there. Once the mean is in for the Poisson calculator, distribution calculator, you can calculate whatever probability they're asking for. So what are they asking for in this problem? The probability that on a randomly selected day, he wrote at least one check. At least one means one or more. So that means 1, 2, 3, 4, 5, up to however many. But as a probability, that would be the probability that x is greater than or equal to 1. So I'm going to change the symbol to greater than or equal, change this to a 1, and then hit compute. And you can see that it shows me the values that are 1 or bigger are in red now, and that all of those are in red, and the total for all of those is here. So it looks like there's about a 41% chance on a particular day that he wrote at least one check. So it says to round this to 3 decimals. So if I do that, I would stop at the 5. It looks like I do not need to round up the 5. And that's what they're looking for. So hopefully that helps. Just to point out, you can set the calculator for the Poisson distribution probability to a specific value, to larger than a value, less than a value, including the value. And you have to just work out from the statement of the problem what they're looking for, and then this calculator should do it for you. Keep up the hard work.